And today what I wanted to do was go back and show you the sorts of questions that you will be asked on the grade 11 work in your trials and your final paper. Sometimes these questions are a little bit easier, and sometimes they can actually ask us things that are quite difficult. So I've got a mixture of stuff for us today. We're going to start off with something that's a little bit easier, and then we're going to end off with something that's going to be a little bit more challenging. Okay, I just wanted you to be exposed to those questions because it's not always going to be straightforward work, unfortunately. Okay, so we know our formula for distance, midpoint, equation of a line, gradient of a line, and obviously for angle of inclination. We are not talking about circles. Today, we're just talking about the grade 11 analytical geometry. Okay, so let's have a look at the first question. I hope this is big enough. If you want me to make it bigger, I can certainly do that. I just wanted you to be able to see the question together with the diagram, or the questions together with the diagram on the same page, especially if you wanted to take screenshots. We can always move things around later. Okay, so it says to us in the diagram, A and B with coordinates -6, -5, and C with coordinates 8 and -4 are points in the Cartesian plane. F has the coordinates 3 and 3.5, and G are points on line AC such that AF equals FG. Okay, so if we consider line AG, we could also say that F is the midpoint of AG. Okay, let's carry on. All right, so the first thing that they want us to do is they want us to calculate the equation of AC in the form y equals mx plus c. Can you see it's out of 4 marks there? The equation of AC in the form y equals mx plus c. I would like to see you guys do that by yourselves without my assistance. We're going to mark it. It's out of 4 marks, okay? And I'm going to give you 5 minutes. Okay, so I'm timing you. Off you go. When you're done, we're going to do what we always do. I'm going to say done in the chat, and then you guys are going to DM me or DM Neliswa your answers. Okay, all right, go. Okay, cool, Nhlanhla, well done. Okay, DM me your answer. Okay, Nhlanhla. Okay, so Nhlanhla's fine. Everybody else, how are we doing? And Nhlanhla, you can carry on to question 3.1.2. You don't have to wait for everybody. Okay, cool, Tamia, well done. DM me your answer, please. And Gugu, good job. Well done, Gugu. Please DM me your answers. Good, Boitumelo. Okay, so DM your answers. And if everything is okay, you can carry on with question 3.1.2. Good. Tulisiwe, well done. Mamelo, nice. DM me as well. Okay, Tamia, I'm getting a different answer to you, and you're going to need the correct answer for Gugu. Also getting a different, yeah, Neliswa, you can also DM Neliswa as well, hey? She'll also be able to help you. Gugu and Tamia, I'm getting different answers to you guys. Tamia, which 2 points, and Gugu, which 2 points did you use to calculate the gradient of line AC? Can you tell me? That's correct. Okay, so you've used the correct points, but something's gone wrong somewhere. Okay, so let's just have a quick look at that. Okay. Hang on again. Okay. All right. Tamir, A and C. Okay, so Tamir, you won't be able to use the coordinates at A because we don't have them. All right, but line AFGC is a straight line. So that means in order to get the gradient of AC, we can use the coordinates at F and C to be able to do that. Does that make sense? Okay, so that means that in question 3.1.1, all right, we would have worked out the gradient of AC change in Y. So 3.5 minus what's going to be end up being plus 4 over 3 minus 8. That's fine. Welcome, Leanne. Nice for you to be here with us. Okay, and then when we pop that into our calculator, I'm getting minus 3 over 2. Yes, that's it. Okay, so don't know what happened. Tamia, Mamelo, Gugu. Okay, you should have been getting -3/2. And then, yes, Gugu, go for it. You're welcome to speak, Gugu.
Hello, ma'am.
Hi, Gugu.
So I don't know if the problem is with my calculator, but even if I input the same values that you inputted right now, I still get -1,1.
Okay, you know what I think it's got something to do with, Guru? I think it's got something to do with the way in which you are putting your values into your calculator. What you need to do, okay, because sometimes what we ask our calculator to do, what we mean and what we tell it to do can be two very different things, okay? So this is what I did, all right? I pressed the fraction button, the one that looks like this. And then when I was up at the top here, I want to be in this block over here, I pressed Shift and I pressed the fraction button again. All right. And then what that did is it did this to my numerator. It gave me this like that. Okay, and then I put my 3 and my half in. You cannot put in a fraction and then go to the front and put in the 3, because if you do that, then you are telling the calculator to multiply the 3 by the half and not add it.
Okay, I see
and
it now, ma'am.
does that make
Thank you so
sense to you?
much.
And then you press
Yes,
the
it
plus
does.
4, and then down into the bottom go 3 minus 8, and then you'll see you'll get the same answer. Okay.
I'm getting the same answer now.
Awesome. All right.
Thank you.
Lovely.
Thank you so much, ma'am.
No, it's a pleasure. It's a pleasure. And that's one of the reasons actually why I want to do questions like this with you, because so often what we think we're putting into the calculator and what we're actually telling the calculator to do are two different things. If you want to put in a mixed fraction, and you guys press the fraction button. So let's say you want to put in 7.5. If you put in the fraction button and then you do this, and then you go forwards and you put the 7 over there, you are telling the calculator to multiply 7 by a half, where in actual fact, 7.5 means 7 plus a half. Okay, so you've got to go shift and fraction if you want a mixed number. Okay. All right. Yes, you can do that too, Leanne. You can change the 3.5 to 7/2. Okay, not a problem at all. Okay, so then we would have come back here and we would have subbed in, presumably, I think it's easier to work with point C. So we would have subbed in the coordinates at C, which are 8 and -4, and then we could have worked out the value of C. You should have got a value of C of 8. Okay, so that means that the equation of line AC, you should have y equals -3/2x plus 8. So what I did here is there is their memo as well, if you guys can see that very quickly. Okay, they've done exactly the same as us. They've worked out the gradient of AC or FC, subbed in the point, and then got that answer. So there you can see subbing in of the values into gradient formula, calculating the gradient, using that gradient, and then subbing in the 8 and -4, and then getting the equation of AC. Okay, everybody happy with that? Yes, sorted. Okay, let's just go back up. There's the questions. Okay, all right. So now on to the second bit, the coordinates of G. Now remember, in analytical geometry, we always use the things that we have calculated to help us to move forwards, all right? So we know the equation of line AC. They want us to calculate the coordinates of G if it is given that the equation of BG is 7x minus 10y equals 8. All right. Again, I think I'm going to let you guys do that. You should know how to do this. I'm dropping major hints here. It's out of 3 marks. Are we okay to do this one on our own? Thumbs up? Yes? Yes, 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 yes. Okay, okay. All right. Off you go. Again, I'm going to give you a few minutes. When you're done, say done and DM me your answers. Cool, Mamelo. I don't think that's a new hand for Gugu. Cool, Nhlanhla, no problem. DM me your answers. Good, Nhlanhla, well done. Okay, Nhlanhla, go on to question 3.2. You don't have to wait for us. Okay, Amahle, no problem. Okay, so I'm so glad that you said that you didn't know what to do, Amahle. There's nothing wrong with being honest about that. That's why we're here. Okay, so Amahle, G is a point and it is the intersection point of 2 straight lines. Okay, so the only way that you can solve for the coordinates of G is to do it simultaneously. So you're going to use your equation for AC that you've already got. Okay, so let's just put 3, 1, 2 over here. You know that AC is the line y equals minus 3 over 2x plus 8, right? We got that from 3.1.1. And they have told us that the equation of BG, I'm just moving this down a little bit, guys, I hope you don't mind. The equation of BG is 7x minus 10y is 8. So 7x minus 10y is 8. So now we need to do a simultaneous solution. Okay, Amatle, you know what to do now. You're going to sub in. Okay. Okay, no problem. See what you get for D. All right, let's go back and see. Daka, that's great. Well done. DM me your answer, Daka, what your coordinates are. Let's see what you got. Okay, Nhlanhla, good. That's fine. Nhlanhla, now go and have a look at question 3.3. You have to prove that line EF is parallel to line BG. Let's see if you can do that. Okay, Daka, that's not what I got. Is that for the coordinates of G? So they should both be positive, Daka, because G is a point in the first quadrant. Okay, Mamelo, DM me your answers for the coordinates of G, please. I just want to see what you got. Okay, good, Linda. Well done. Good, Mamelo. Good, Tara. Good, Leanne. Yes, perfect. Excellent. Well done. Okay, nice one. You guys are doing good work. Good, Tulisiwe. Well done. All right, so this was a simultaneous solution. Very nice. Yes, boy too. Lorraine. Hopefully you got the same answers as everybody else. 4 and 2. Good, Gugu. That's excellent. Well done. Okay, so just very quickly, we would have done a simultaneous solution. Easiest thing for you to do here is just go and sub equation 1 into equation number 2. So we've got 7x minus 10 times y is minus 3 over 2x plus 8. And that is going to be equal to 8. And then we can solve for x and go back and solve for y. Okay, so this would have given us 7x plus, that would be 30 divided by 2. So that would be 15x. And then that would be minus 10 times 8 would be 80 is equal to 8. So on the left-hand side, we would end up with 15 plus 7. So that would be 22x. And on this side over here, we'd have 88. Divide both sides by 22, and you should have got that x is equal to 4. Solving for y now, I'm just going to write it up here. Y would be equal to minus 3 over 2 times 4 plus 8. So that would give us negative 12. Negative 12 divided by 2 is negative 6. Negative 6 plus 8 would be 2. Remember, if they want coordinates, give them coordinates so that we don't get penalized. 4 and 2 is the right answer. Okay, so that was out of 3 marks. Solving simultaneously, a mark for X, a mark for Y. Okay, now the next one. Show by calculation that the coordinates of A, or the coordinates of A is 2 and 5. Remember, we've just calculated the coordinates of G. We know that it is 4 and 2. How are we going to get the coordinates of A, Matrix? Can someone unmute and tell me, how would we do this? What are we going to use? How would we work out the coordinates of A? There we go. Good, Leanne. Good, Onwaba. Okay, so we're going to use midpoint and we're going to work backwards. Okay, we've got F. F is the midpoint of AG. Good, well done. Yes, Amatle. Right, we are not allowed to sub in the 2 and the 5. Okay, that's what we have to prove. So very important how we set this out. Okay, what we need to do is I'm going to rub off 3.1 because we're finished with that now. And if we need that information, we can get it easily enough. Okay, so when it comes to 3.2, yes, Nonjabulo, you may ask why we're using midpoint. Okay, so Nonjabulo, can you see, just look from A to G. Just look at AG. F is the midpoint of AG. It tells you over here, AF equals FG. So we're going to work backwards using midpoint formula. So in other words, the X at A plus the X coordinate at the other end, which would be 4, divided by 2 is going to be equal to the X at the midpoint, which in this case is 3. Cross multiply. So the X at A plus 4 will be equal to 6. And now transpose that 4 and we get the X at A, which would be equal to 2, which is what we want. Okay. And we do exactly the same thing with the Y coordinate. Okay, the Y coordinate at A plus the Y coordinate at G, which is 2 over 2, is equal to the Y coordinate at the midpoint, which is 3.5, or like Leanne said earlier, let's use 7 over 2. So because both of these are over 2, we can actually drop the 2. We can multiply, but our denominators are the same. Okay, so if our denominator, yes, absolutely. Sadiso, perfect. Does that make sense to you now, Nonjabulo? So now we have the Y at A plus 2 equals 7, and therefore the Y at A would be equal to 5. Okay, so therefore the coordinates at A are 2 and 5. Remember, this was given to us. Okay, so it's a very common question, all right, where they ask you to work backwards with midpoint. They give you the coordinates at the midpoint. You've calculated the coordinates at G in this case, and now they ask you to work out the coordinates at A or show that they are 2 and 5 by working backwards. So yes, this method that I am using in question 3.2 is very, very, very important to you guys. Okay. All right, let's move on and talk about, so far, theoretically, what we would want is full marks for all of this. We've got 4, we've got 3, we've got 2. All right, so that's 9 out of 17. Okay, we would want 9 out of 17. Let's see if we can get the other 8 marks that are still remaining in this question. All right, next thing. They want us to prove that EF is parallel to BG. And that is out of 4 marks. So now we have to start thinking about geometry, not just analytical geometry, but geometry that we did back in the first term. How do we prove that lines are parallel to one another when we do not have any angles? What can we use? Okay, you guys are saying we can use gradients. Good, I like it. Sisipo, you could use the proportionality theorem. Good. On Wabasane gradients. Do you know what? You're all correct. You're all correct. We could use the converse of the proportionality intercept theorem. That might be a little bit more difficult. We could use midpoint theorem because after all, F is the midpoint of AG, we could calculate and see whether E is the midpoint of BA, or we could use gradient. If we can work out the gradient of EF, and that's the same as the gradient of BG, then we know that those lines are parallel to one another. Okay. All right. So now the question becomes, if we did decide to work with gradient, because that's sort of the first answer that came up, how would we work out the gradient of line EF? How would we work out the gradient of line EF? Or what do we need, Leanne? Go for it.
Ma'am, I think we're gonna first find the coordinates of E using the line AB.
Good, good, well done. And then E would be the x-intercept of AB, just like it tells us up here. Okay, good, Leanne, well done. E is the x-intercept of AB. So if we can get the equation of AB, we can work out the coordinates of E, because it is the x-intercept of line AB, and then we can calculate the gradient of EF. All right, well done. Very, very nice. Okay. Okay, but just be careful on Waba and Amatle. We don't know that E is the midpoint of AB. Okay, it is, but we can't assume that it is until we've proved it. Okay, so rather get the equation of line AB and work out the coordinates at E using making it as your x-intercept. Okay, we don't know that AE equals EB. We've not been given that, and we haven't proved it. Okay, so if you use information that you haven't proved or you haven't been given, then you will be penalized for your answer. Okay. Neliswa is saying, can we say that FE is perpendicular to AG. What would be our reason for that, Neliswa?
I was thinking because you were saying that you can't just assume something that you are not given. So you have to look at what you are given. So looking at A and G, I think AF is equals to FG. One can assume that EF is perpendicular to AG because it bisects that line. So I was just trying to ask a leading question.
No, that wouldn't work in this case, unfortunately. If we had a circle, then we could do that. We have got coordinates. We have got coordinates now, though. We could use that to see whether the product of their gradients was -1. But that will be the easiest, But the easiest way for them to do it, okay? Get the equation of AB, work out the coordinates at E, and then work out the gradient of EF. Okay, all right, guys, go for it. When you get the equation of AB, just DM me your answers, okay, so that we can check that you guys are on the right track. Okay, Gugu, you're a little bit faster than me. Hold on, I'm coming. I'm getting a different answer. Okay, Nhlanhla, you getting the same answer as Gugu. Am I going crazy then? So Gugu and Nhlanhla, you are working out the equation of line AB, right? I'm getting a different answer to you guys. Wow, maybe I've done something wrong. Because you both got the same answer. Okay, let me just do it again. Okay, so Lorraine, yes, because we would have just been able to rearrange that. Okay. All right, I must have been just doing something really stupid, guys. Okay, so all of you are saying that the equation of AB, so let's get this out the way. The equation of AB is 5 over 4x plus 5 over 2. Okay. All right. Okay, so now let's work out the x-intercept. Okay, so in other words, the coordinates at E. Good, Thuli? All right, so what are you getting as the coordinates at E, guys? Okay, and Nhlanhla, your answer's a little bit different to everybody else. Amahle, yes. Okay, let's just see. Okay, so Tamia, please, do you want me to explain how I got the equation of AB? Tamia, is that what you're asking about? Yes, Gugu. Yes, Leanne. Yes. Oluhle. Yes, Nobasutu. Sisipo. Okay, good. Now that you've got, okay, so I'm going to come back to you now. Now that you've got the coordinates of E, work out the gradient of EF. Okay, Tamia, you're going to listen to me. Everybody else, work out the gradient of EF. Okay, so Tamia, when we want the equation of a straight line, we're going to work out the gradient of AB first of all. Okay, Tamia. So the gradient of AB is the change in Y. So if we say 5 minus 5, that would be 5 plus 5 over the change in X. So that would be 2 minus negative 6. So that would give us 10 over 8, which is 5 over 4. There's the gradient of 5 over 4. And then they're subbing in. Okay, so into y equals mx plus c, so 5 over 4x plus c. The easiest point to sub in is a, Tamir. So that would be 5 equals 5 over 4 times 2 plus c. And then when you work out the value of c, you'd get 5 over 2. That's where it comes from. Okay, good on Waba, I agree. Okay, so to get the x-intercept, we would make y equal to 0. Okay, so I'm going to times both sides by 4. And if I times this side by 4, that would be 10. So x would be equal to negative 2. Lovely. So that's why you guys are saying the coordinates at E are negative 2 and 0. Good. Now, let's calculate the gradient of line EF. There we go. You guys are getting 7 over 10. All right, so that's 3.5, which is 7 over 2 minus 0 over, okay, so that's 7 over 2. I'm also getting 7 over 10. Well done. And we know that the equation of line BG is 7x minus 10y. So for BG, we know it's 7x minus 10y equals 8. So if we get that into standard form matrix, we would end up with 7x equals, sorry, beg your pardon, we want 10y on its own. Sorry. We would say minus 10y equals minus 7x plus 8. We would divide through by negative 10. That would give us y equals 7 over 10x plus 8 over 10. So that would be 4 over 5. Okay, so what this means for us now, right, is that the gradient of EF equals the gradient of BG. Okay, therefore EF is parallel to BG. Okay, on WABA, I don't know why you got 3 out of 10. Maybe you pressed something funny on the calculator. Yes, Gugu. Okay, are we all right up to this point? This was question 3.3. This is where it started, question 3.3. Okay, Daka's okay. How's everybody else? Ntlanhla's okay. Lebogang, Nabasutsu, Tuli, Gugu, Sisipo. Okay. Oh, good on Waba. You must have just suppressed something funny on the calculator. Good, Linda. All right. Well done, guys. Tapiso, Boitumelo. Nice. Okay. So let's finish Chorizo. Okay, cool. I'm glad you're happy. All right. So let's finish this question off matrix, and then we have done 17 marks, and hopefully we all have 17 out of 17 going forward. Yeah, Linda, where's the mark allocation? Good question. Okay, so it's out of 4. So the important thing here would be we would have to have the gradient of EF. We would have to rearrange this and show that the gradient there is the same. So that would be important. I also think that there would be a mark for calculating the coordinates at E, and I think for the equation of line AB. Okay. All right. Okay, Linda. Okey-dokes. Okay. Let's do the last question. Now it says to us, A, B, C, D is a parallelogram. Okay, now they don't give us point D. Pleasure, Linda. A, B, C, D is a parallelogram with D in the first quadrant. Calculate the coordinates of D. So these questions are also very common in grade 11 analytical geometry. And what is very important here is the order of the letters, matrix A, B, C, D. Okay, so if you have got a shape A, B, C, D, let's just write this down here. Okay, let's pretend I can go A, B, C, D like so. Or I can start anywhere. I can start at any point, but I have to either work clockwise or anti-clockwise. I cannot do this. So I'm not allowed to go for example, A, B, C, D. Okay, that's not correct. So when you name a quadrilateral, you are either working in a clockwise direction or in an anti-clockwise direction. So that is important in helping us, yes, in Klantla, parallelogram. Okay, now D is not drawn. D is not there. Okay, so that's why we've got to be so careful about where D is. Now, they've told us D is in the first quadrant. So here's our first quadrant up here. Okay. It's not on the diagram, Lebogang. We're going to have to put it on. That's what makes this a more difficult question. Okay, so in other words, D is somewhere up here. You see where I'm putting this big blue dot? D is no. A doesn't become D. Right, so look here. I know, Michael, I see you got your hand up. Okay, so A, B, C, and then D is somewhere up here. Okay, like so. Okay, A, B, C, D. Right, obviously that line and that line are supposed to be parallel, and that line and that line are supposed to be parallel. Can you see it now, Matrix? Okay, A does not become D in Klantla. D is a different point. Okay, does that make sense to everybody? Not a Z shape, although I suppose you can say D, A, C, B, that would be a Z. Yes, Leanne, essentially here you are constructing. Okay, but you don't actually have to draw in D. You just need to know where it is on the Cartesian plane in order to be able to calculate its coordinates. Okay. All right. So let's work out what its coordinates would be. Okay. All right, so A, B, C, D is somewhere up here. In fact, I haven't even got D. I mean, it's more or less in the right place. But if I wanted it to look like a proper parallelogram, what I could do is move my questions over a little bit and just try that again. Okay. Okay, I'm just rubbing all of that off. And I'll just show you guys one more time where D is located. Okay, so AB is parallel to CD. So D is somewhere over here. These lines have to be parallel for it to be a parallelogram. And AD is parallel to BC in order for it to be a parallelogram. Okay, you see the order starting here, and we're going in an anti-clockwise direction. A, B, C, D. Here's D, somewhere up here in the first quadrant. Okay, can everybody see that? No, we can't say that, Oluhle. If we connected B and D together, and we've already got A and C, we could use midpoint, because remember, in a parallelogram, the diagonals bisect each other. So what you could do, yes, Mamelo, you could find the midpoint of AC and then you could work backwards. Yes, that's one way of doing it, 100%. There's another way using translation. Okay, so the first way, so the gradient of AD and the gradient of BC would be the same, and the gradient of AB and DC would be the same, but that wouldn't help you find the coordinates at D. Okay. So the coordinates at the midpoint of AC, wherever that is, let's call it M, that would be the same, okay, as that over there, because the diagonals of a parallelogram bisect each other. Okay, so that would be one way to do it. Right. Unfortunately, what's happening is that we're now running out of time. I've got to go to the next class. But just maybe, Neliswa, if I'm just finishing off a little bit late, although I've got load shedding starting. If we want to calculate the coordinates of M, the midpoint of AC, remember here, this was 2 and 5. So we could say 2 plus 8 over 2 and 5 minus 4 over 2. So the coordinates at M would be 5 and 1 over 2. Now to work back to D, okay, the x at D plus the x coordinate at the other end, so that would be -6 over 2 is equal to the x coordinate at the midpoint, which would be 5m. So cross multiply, the x at D minus 6 is equal to 10. So the x at D would be 16. Same story with the y's. Okay, let's just move this over. Okay, so the y at D plus -5 over 2 would be equal to the y at the midpoint of M, which is 1 over 2. So the y at D minus 5 equals 1. So the y at D would be equal to 6. So therefore, the coordinates at D would be 16 and 6. Okay, that's one way to do it. Was that difficult, that question? Yes. No, Palesa says not too much. Anwaba says no. Okay, Tamia, yes, fine. Okay. Una says yes, it was tricky. Okay, well, I'm glad that we did something that it was at least a little bit tricky for you guys.